Okay, welcome to the next chapter. This is the first lesson in our second chapter. And for those of you that are actually watching these and using these to study, welcome back. Those of you who aren't, you're not listening to this, so oh well, here we go. Of course, we start every class with putting our phones in the caddy and looking at our goal. So we're going to talk about minerals in this chapter. So our goal today was to know what makes something a mineral versus what makes it a rock. And the question to start the class was, what was the difference between a mineral and a rock? And we had a discussion on that, and we saw where that went, and then we dove right in. So there was a little bit to write down in the notes, of course. What we write down in the notes is in red, and the extrapolation is in black. You don't have to write that down. Let's begin. Okay, so we think of minerals as the building blocks of rocks, and we begin our discussion of earth materials with an overview of mineralogy, which is the study of minerals. And minerals have been around and used by humans. I mean, minerals have been around forever, but they've been used by humans for thousands of years as both decorations and as useful technology, from the flint used to make weapons and basic tools all the way up to the silicon used in our computers today. And think about that, 3,700 years of evolution, and we went from chipping up pieces of flint to make a basic weapon or cutting tool, all the way up to the technology we have today, where I'm able to record a lesson and transmit it over the internet to anybody anywhere in the world on a moment's notice, basically. And that happened in 3,700 years. Contrast that with dinosaurs that roamed the earth for over 165 million years, and they didn't develop any kind of technology that we can think of. So as a human species, it's really incredible what we've been able to accomplish in a relatively short time span, 1/100th the time that dinosaurs have been here. Okay, so here's where we define what a mineral is. A mineral is any naturally occurring inorganic solid that possesses an orderly crystalline structure and a well-defined chemical composition. Minerals exhibit the following characteristics. They're naturally occurring, solid at normal temperatures you would encounter on the Earth's surface. They have those orderly crystalline structures, well-defined chemical composition, and they are generally inorganic. So that was all within the definition we had at the beginning, and then I went on to expound on each one. So naturally occurring means that the mineral is formed by a natural geologic process. This means that synthetic diamonds, rubies, and other useful materials that are not considered minerals, even though they're not considered minerals, even though they might have the same composition, but because we've made them synthetically, they're not classified as minerals. They are solid at normal temperatures on the Earth's surface. So, ice in an iceberg is technically a mineral. Because that's at a normal freezing temperature in the north. That happens naturally. But the ice made in your refrigerator, your freezer, that is not a mineral because it is man-made. Orderly crystalline structure. Hopefully you've had chemistry in the past, or at least physical science, and gone over, crystalline solids and amorphous solids. So in the crystalline solids, the molecular shapes have an orderly pattern, and when they come together as a solid, that pattern repeats itself, and you get these iconic crystal shapes. Like quartz has those all those angles in the facets. Salt crystals are all 90-degree angles. They make the little cubes and things like that. So you have the orderly crystalline structure. If a naturally occurring solid does not contain a crystalline structure, such as obsidian, which is volcanic glass, that is not considered to be a mineral. Even though it's solid and naturally occurring, it's not a crystal, so it's not a mineral. And they have a well-defined chemical composition, so most minerals are chemical compounds made up of two or more elements. Since the elements combine in specific ratios, they have a specific chemical formula. There are some minor variants in the chemical reactions in minerals, but they're still really similar, and they just manifest as the variety of colors we see in things such as quartz, whereas you have like clear quartz, which is white, or amethyst, which is, you can think of that as just purple quartz. And there's a picture of each one, and I do like the amethyst. I think it's prettier. but your mileage may vary. Okay. Okay, they are generally inorganic. Inorganic compounds are those that do not have a carbon hydrogen bond in them. There are many crystalline solids made by living organisms in nature that are not considered minerals, such as sugar. Sugar, is naturally occurring and it's made by plants, but it's all carbon, hydrogen, and oxygen. So that is an organic compound, so that is not a mineral. That said, there are some marine animals that secrete inorganic compounds, such as calcium carbonate. That is classified as a mineral. So these coral reefs, the coral is a mineral, even though it was secreted by marine life. Okay, and then rocks. A rock is any solid mass of mineral or mineral-like matter that occurs naturally as part of our planet. Some rocks are composed almost entirely of one type of mineral, while most others are aggregates of several kind of minerals. So if you want an analogy for this, you can go back to your chemistry, physical science class days and think of like when we did mixtures and compounds, you know, rocks and minerals, we can think of them as like mixtures and compounds. Rocks are like mixtures because they don't have specific chemical compositions, and minerals are like compounds because they have specific makeup with those minor variances that appear as color. And then we ended the class, the lecture portion of the class at least, with a look at the periodic table, discussing the structure and organization of the table, and then we did a review homework that was in the Schoology folder, just going over the basics of the periodic table and basics of atoms and bonding. And then that was how we ended the class. So not a whole lot to write down, pretty short lesson. I hope this helped you out, and we'll see you in the next one.